In this video, we're going to explore how composition works inside of Compose UI. So, composition could be divided into three steps. The first is to take your compose code and to generate a slot table. The slot table contains information such as the state you're holding on and all the nodes in your Compose UI. And here's an example of it. Each entry in this Compose UI tree has a group associated with it, has a key associated with it, and slots. So we're also going to take that information in the slot and materialize it, and it will emit basically a node in this tree. So this is the Compose UI tree of the Compose code that I just showed you before. So the next step is to take that information to lay things out based on constraints. We're going to figure out what the width and height is going to be, what the placement and alignment will be. And the last step is to draw on the canvas. So let's look at how this works. So suppose you had a very simple example of a column with a hello text in there. And what you wanted to do is to build this slot table that looks like this. So this is a portion of the slot table. There are a lot more information in there. This is a snapshot of what this table would look like for this piece of code. So how is this code created? The first thing you'll see is that each column so the column in this case is a layout node. So each in the Compose UI tree, each item emits a layout node. So, and this layout node has a specific group value and also a key value, and also has an associated measure policy. It could be either a row, column, or a box. So you could also see that there's also information about the text. The text in this case is a child node of column. It also has associated key and group value. So inside of the composer, so when you look at the compose internals or runtime internals, you'll see that there is a composer that handles being able to build a slot table, and it has a method called doCompose, and there are trace methods, and these trace methods are useful when you have debugging on for instrumentation. So you could see like different steps that executed when your UI was built. So in the recompose step, there is a method in there. There's logic in there that goes and creates a slot table and starts by creating the root node. There's always a root node in the slot table. And then what it does is that it begins to look at your compose code. And the compose code, what you'll see is that the compiler plugin, it generates code to hook into the runtime to be able to communicate with the composer. And what the composer is going to do is going to look at your compose code, is going to apply certain changes at the end to be able to update the slot table. And these are some of the changes that is going to have, like update node, insert node, things like that. So as it's analyzing your compose code, it's forming these change lists at the end. So what does that look like? So what this looks like is that when you look at this column and the way it converts it into a UI tree is like this. Here's an example of a UI tree where each node here, each entry, like column, text, or you could have a row, is a specific layout node in this tree and has a measure policy associated with it. So there is a layout node class that is being created for each of these items. And there is a parent and child relationship here. So when you look at a layout node, the information that it has is that it has specific things that are always set, which are like the modifiers, the measure policy, in this case it's a row, or a composition key hash, which is a unique identifier for a composition scope. And there's also like composition locale provider that gets set. So for each layout node has this information associated with it. So when you look at a column internally, what it's doing is that it's setting up the measure policy and it's calling this layout class. And this layout class is internally the class that sets up all of this information and creates this node, this reusable node. So each item, each row, box, or composable method that you call, it basically creates a node internally. The compose UI creates a node for it in the UI tree. And what happens is that the compose runtime is able to tell compose UI that I need you to update this tree based on either some action that happened or some animation. So here's an example of it. So when you look at the source code for a layout node, you'll see a bunch of internal functions such as inserting a node at a specific location, being able to remove all the nodes. So these are methods that are called when you take actions in the UI, such as clicking a button and so the information that you see in the UI, all of the UI elements are structured in a tree, and these methods are being called as recompositions are happening. And so what happens is that when the changes list gets created, it has to tell compose UI to be able to update this tree. And what it looks like is that the compose runtime communicates with a UI applier. When you hook into compose, you always specify an applier which is responsible for taking in commands from the compose runtime and updating this UI tree. It has a reference to the root layout, and it's able to traverse this tree from the root, and it's able to remove certain things at a specific index and remove things. And the information about like what to remove, like what index to go to in that tree, it's all in this changes list. And the UI applier is basically reading from this changes list to do the updates. So here's an example of a specific specific change list. So when a UI gets displayed, and the compose runtime is going to compose UI is going to basically mutate the tree, is going to add certain things to it. In the initial composition, it will add to the root layout a column, for example, and is going to it knows like what measure policy to add in, what index to add it at. So that's an example of a layout node command. So each layout node has an owner. There is a specific UI element that is holding on to the root layout node. And in compose UI, there is a owner specified, which is going to be is going to have a specific layout node. And the owner, for example, could be an Android Compose view. This is an internally in Compose UI, there is something called Android Compose UI, which attaches a root layout. And what it does is that it creates a root layout node. It creates a root layout node, and it acts as an owner. It inherits the owner interface, and it attaches and detaches when your UI either tears down or when it initializes. So let's look at another example where you have a column with a button. And this is what the compose UI tree would look like. You have a column with a button, and then there are two different branches that it could go into. You could have either on the left a node which displays hello world 1, or on the right a node that displays hello 2, and which the way this tree is structured at any given moment is based on this if check. So the way when you click on that button, it has to mutate the tree. And what compose does is that it creates a changes list to tell compose UI to mutate the tree. And the commands that it will give it in the layout class is that layout node class is that it's going to have a command to remove the layout node, to remove a specific layout node from the tree, and to add another one. So when you add animations, this happens like on a continuous spectrum, and when you don't add an if check. So this is an example of how the UI tree compose UI tree is mutated, inside of the layout node of a layout node. So this is an example of what happens during composition and during layout and when you're drawing. So when you're laying things out, it has to be able to the layout node has to be able to take in the constraints and has to be able to figure out how to lay things out, how to lay each of these nodes out. And the way this works is that a layout node has different states. Each layout node has different states, which is measuring, layout, look ahead measuring, laying out, idle. And it's able to go from one state to another, and it internally utilizes delegates. There's a measure delegate, a lookout ahead delegate to do this. And the way these states go from one to another is by, it starts off at an idle state during initial composition, then it goes then it moves towards measuring, then it moves towards laying things out, then it goes back to an idle state. So this is like a state machine, and inside of the layout node class is interacting with certain delegates to be able to interact, to be able to do this, and that's what we'll look at in the next video. So this is a snapshot of what happens during composition, that we're constructing the slot table. The composer and recomposer are working together to construct the slot table. And then we're going to construct this UI tree. We're going to utilize that layout node class to be able to set up child and parent relationships, to be able to attach nodes to this. So in the next videos, we'll look at in more detail how layout happens, how it utilizes certain delegates to be able to set up constraints. That's what we'll look at in the next video. Thank you.